Good morning, everyone. Welcome to the video lecture series of the Power Electronics and Instrumentation, module number 1. Let us study how the turn-on methods are used, okay, or what are the various turn-on methods which are there in the power electronics or for the respective thyristor. Okay, in the previous video lecture, I have just completed the topic of turn-off method or turn-off mechanism of the SCR. Okay, so let us go with the turn-on methods. Okay, what are the various different methodology we can use for turning on of SCR? Turning on. Okay, it's not off; it is turning on of SCR. Okay, so let us go with this particular topic here. Okay, because there are a lot of things are there in the turn on methods. Okay, if you look at here, okay, the turn off methods. So basically in the turn off methods, okay, we have different type of the triggering mechanisms. Okay, so here in the turn on methods, okay, we have first is the voltage forward voltage triggering. Okay, what do you mean by the word trigger? Is nothing but it's a fire. Okay, you know the general meaning of the trigger. Okay, if you take a pistol or if you take a gun, okay, there is a trigger. Okay, so until and unless you do not trigger that button, the bullet will not come out of the pistol or the gun. Okay, it's just like the same mechanism, same concept here. Okay, so it is a forward voltage triggering. Okay, so what do you mean by the word forward voltage triggering? Is in this method of triggering or the turning on of SCR is nothing but it is triggering without the application of the gate voltage. Okay, with only application of large voltage across anode and cathode such that it is greater than the forward breakover voltage VBO. Okay, so this type of turn on is destructive and should be avoided. Okay, this is the one type of mechanism which is mentioned here in the topic of turn off methods, turn on methods. Okay, what this turn on method say, the first turn on method says that if this is my SCR, okay, and if this is my anode and this is the cathode here, okay, there is the one terminal, we call it as a gate. Okay, so usually what happens in the SCR is when you apply the voltage across the anode and cathode, that is the positive voltage across the anode and cathode. Okay, so the SCR will be in the forward blocking state. Okay, the SCR here, it will be in the forward blocking state, forward blocking state. It is in the blocking. So therefore here what happens exactly in the SCR here is whenever I supply the voltage across the thyristor. Okay, here this is the plus and this is the minus. Okay, let us call this as the voltage. This is called as the voltage, or let me call it as the VF. VF is nothing but the forward voltage which is applied across the anode and cathode. Okay, so once I start applying the voltage across this particular part, okay, the current will flow in this particular direction, and this current, okay, will be at the anode part, but it will not be allowed to flow from anode to cathode until there is sufficient amount of gate voltage. Okay, the sufficient amount of the gate voltage, or we can call it a sufficient amount of the gate current, called as a IG. Okay, so therefore here what happens in the forward voltage triggering is what we will do here in forward voltage triggering is we will make the voltage, that is the forward voltage VF, okay, or the battery which we apply to this SCR is VF will be made greater than the current IG, or you can take it as VG, gate voltage. Okay, so once you increase the amount of forward voltage, okay, beyond the forward gate current, okay, which is nothing but a minimum current. For example, if your IG current is equal to something around the 5 ampere, okay, if you put a 5 ampere of current across this particular gate voltage, then it will allow you to flow the charge from anode to cathode. Okay, irrespective of your forward voltage. For example, if the forward voltage, if I applied, is 4.5 voltage here, okay, but this 4.5 voltage, it will not turn on my thyristor, it will not turn on my SCR, because until and unless if I do not apply the gate current, sufficient gate current, it will not allow the flow of charge. So what the another method what we can adopt in turning on the SCR is, we will increase the forward voltage beyond the forward gate current or the gate voltage. That is nothing but Vf should be greater than Ig or Vg. If this happens, what will happen to the SCR? The SCR, it will damage. If you do that condition, okay, what happens is SCR gets damaged. SCR get damaged. This should be avoided. This should not be made considered. That is what it is mentioned. Okay, this type of turn on method should be avoided. This is possible, but it will damage your SCR. So this type of mechanism cannot be adopted in the application point of view. Okay, this is just the one method of turning on the thyristor. Okay, so this is the first part of the turn on methods of SCR. Okay, so let us go with the second method of turning on of the SCR. Here is the thermal triggering. Okay, the second mechanism which we do here is, it is thermal triggering. We know what do you mean by the word called as a thermal. Okay, thermal is nothing but it's a temperature. Thermal is nothing but it is the temperature. Okay, so if the temperature of the thyristor is high, okay, there will be an increase in the charge carriers, which would increase the leakage current in junction J2. Okay, and this particular junction J2, it will cause the thyristor to turn on. So this type of turn on may cause thermal run away, and it usually avoided, because more increase in the temperature, it may also again lead to the destruction of the thyristor. Okay, basically what happens here is, if this is my thyristor, okay, which is applied to a voltage of, or the forward voltage of a Vf. Okay, and if this is anode and this is the cathode, if this is my gate terminal represented by G. Okay, due to this the normal operation or the normal turning on of this SCR is nothing but I should apply the sufficient amount of gate voltage or the gate current. Okay, so we know the temperature here. Okay, so increase in the temperature is nothing but you should make the conditions in the room conditions or the condition across the SCR in such a way that even if there is an increase in the temperature, okay, the SCR will change its characteristics. Okay, so increase in the temperature will increase your flow of charge carriers, which in turns, okay, it will also increase the leakage current at the junction J2, because we know the construction of the SCR. Okay, it is a 4-layer, right? It is a 4-layer 3 junction. Okay, if this is my P N, this is P and this is N. Okay, if I apply the voltage at this particular point, that is P and N terminal, okay, and making it this as my anode and this is my cathode. Okay, so which are the junctions here are, this is junction J1, this is junction J2, and this is my junction J3. Okay, even if the voltage is forward bias, okay, junction J1 and J2 are forward bias and this junction J2 is reverse bias. So increase in the temperature, okay, it will causes the increase in the leakage current in the junction. Leakage current in the junction is nothing but increase in the temperature will causes this junction to break. So therefore, the another thing what we can mention here is this particular type of current which we do here. Okay, what this will happen is, this will turn on many causes of thermal runaway. Okay, and even this should be avoided in the SCR. So forward voltage triggering is not permissible, okay, or not advisable, you can say. Okay, and even the thermal triggering is also not advisable. Why this is not advisable? Because this may damage your SCR. Okay, and we should not build any application where there is a possibility of the damage. Okay, we should check the operation in such a way that nothing should be damaged. Okay, irrespective of it is a gate voltage triggering or it is with respect to the thermal or with respect to the forward voltages. Okay, now this coming to the third part of the triggering, which is called as a light triggering. Okay, which is called as a light triggering. Okay, we know the very basic simple concept of the photodiode. Okay, whenever the light falls on the photodiode, okay, it will start to operate. Okay, so therefore what is the light triggering here is nothing but if the light falls, or if the light is allowed to fall on the junctions of the thyristor, that is what the photodiode will do, right? Because light consists of photons, and when the photons fall on the particular the diode, okay, or the particular junction of the thyristor, what it will do is it will, the charge carriers will increase, okay, and then it may turn on the SCR. Then it will turn on the SCR. For example, we have one more, that is LAC-SCR. It is called as light activated SCR, and they are turned on by allowing the light to strike the silicon wafers. Okay, so this is the third type of the triggering, which is called as a light triggering. Okay, then coming to the fourth point is, fourth type of turning on the mechanism is called as a dV by dt triggering. Okay, dV by dt is nothing but the change in the voltage with respect to the change in with respect to time. Okay, look at these particular equations here. Okay, so what is happening in the dV by dt here is exactly is under the transient conditions. Okay, the capacitance of the junction will influence the characteristics of the thyristor. Okay, because the capacitor is nothing but what, it's a two parallel plates. Okay, and the charge will be accumulating on that particular two plates. So therefore here, under some transient conditions, okay, the capacitance of the PN junction will influence the characteristics of the thyristor. Okay, and if that thyristor is in the blocking state, you know what do you mean by the blocking state? Okay, it is not under the active region, it is still the under something called as a forward blocking state. Okay, a rapid rising voltage applied across the device would cause a high current to flow through the device, resulting in turn on. That is what the same thing. Okay, change in the voltage with respect, dV by dt is nothing but what, the voltage, rise in the voltage, change in the voltage with respect to time t. Okay, so as soon as I go on increasing my the flow of current or the flow of charge, okay, so what this will happen here is this will increases my voltage across the anode and cathode, and that particular increase in the voltage in anode and cathode, okay, it will break your junction, or it will allow you to flow the huge amount of current through the device, that resulting in turning on of the SCR. Here you can see. Okay, and basically your junctions whatever we have, that is J1, J2 and J3. Okay, based on the capacitance, based on the concept of the capacitance, okay, the amount of voltage can be made small, or it can be made as large. Okay, as we see here dV by dt, we may also have a di by dt also. Okay, the change in the gate current with respect to the voltage. Okay, whenever there is a high amount of current or the high amount of voltage which flows through that particular junction, then it will make your SCR to turn on. Then we have gate triggering. Okay, here you can see the gate triggering can be done in the three methods. Okay, so the first method is AC gate triggering, DC gate triggering. Then we have pulse gate triggering. Three types of triggering mechanisms we adopt in gate. Okay, so the first is AC gate triggering. Okay, and this is one of the most commonly method of turning on of the SCR, which is used in the industries or applications, or in the in our laboratories also. Okay, this is the most commonly used, is nothing but the gate signal. Okay, in all the applications of the thyristor control. Till now, whatever I have explained in my previous video lectures, I have considered as a gate voltage. I have not considered the dV by dt. I have not considered the light falling on the SCR. Okay, and neither I have considered the increase in the forward triggering mechanism or forward voltage, because everything leads to the destruction of the SCR. Okay, we should not damage the SCR, but still I have to turn on the SCR. So the best way, okay, the best possible way of turning off of your SCR is nothing but it is the gate triggering. Okay, so AC gate triggering is the most commonly method which is adopted in all the applications of the SCR. Why it should be adopted? Because it provides the isolation between power and control circuit. Isolation is nothing but it's a insulation, okay, between your power and the control circuit. Because if there is an insulation, or if there is a kind of an isolation between the power and control, then there is a possibility that your SCR will not damage. Okay, and the firing angle can be changed very conveniently by changing the phase control of SCR. Firing angle is nothing but just take just it is just like you are a protector here. Okay, so this angles are various angles are being mentioned like this. Okay, so usually it starts from 0, we take it from the right side. Okay, 0 degree, 10 degree. Okay, so this will be something my 90 degree, and this will be my 80 degree. Okay, this is the phase control. So even if the 0 degree, I may not get the complete power. Okay, as I go on increasing my or go on changing my firing angle. Okay, this is angle in degrees. Okay, so the firing angle can be changed very conveniently by changing the phase angle of the control signal. Okay, so this mechanism is the simplest mechanism to turn on your SCR. Okay, then but the disadvantage here is that the drive is maintained only for positive cycles. Okay, because it's a AC triggering, right? In AC we have only two cycles. One is the positive, another is nothing but the negative half cycle, right? So in the negative half cycle your SCR is turned off because it is the reverse bias, it cannot be turned on. But in the positive half cycle, what is happening? In the positive half cycle, the diode conducts very properly, and it will be in the forward blocking state, and can be made into the forward conduction state also. So therefore the disadvantage here is that it can be operated only for positive half cycle, not for the negative half cycle. Okay, this is the small disadvantages in AC gate triggering. Okay, so but if you take it to the DC triggering, okay, because DC has a graph like this with respect to time t. This is my DC graph. Okay, it remains constant because there is a frequency is being disabled because we don't have a frequency component in the DC signal. So therefore it gives you the constant line. Okay, so therefore the DC voltage of a proper magnitude and the polarity is applied between the cathode and the gate junctions. Okay, when the voltage is sufficient, the device starts conducting. Okay, but the problem here is that both the power and control circuits are DC, so there is isolation problem. So if you use a gate triggering, the problem is it is only positive half cycle, negative half cycle is absent, but isolation can be done very properly. But if you use the DC gate triggering, okay, there is no isolation, but the power and the gate control cannot cannot be they are in the DC part. Okay, so that becomes a very again small disadvantage if you make use of the DC gate triggering. Okay, so therefore we have one more type of gate triggering here, so which is nothing but it's a pulse triggering, third type of gate triggering. Okay, and this is the very most popular type of gate triggering which is used in the triggering of the devices. Okay, so what do you mean by the pulse here is this is my pulse on and off, this is pulse, right? So this is this can be, this is 0, this is 1, this is 0, this is 1 0 1 and 0, it will just go on continuing. Okay, so therefore what do you mean by the pulse triggering here is pulse triggering is the most popular method of triggering the device. Okay, here the gate consists of a single pulse appearing periodically. That is what I've said, because it is a pulse, it appears periodically because the on and off pulse are of the same size, therefore they appear periodically or in a sequence of high frequency pulses. Okay, and this is also known as the carrier frequency gating. A pulse transformer is used for the isolation. Hence there is no need to apply the gate signal continuously, and hence the gate losses are very much reduced. Okay, because the applications are very well proposed in this particular gate triggering, because along with the isolations, okay, there is no any loss. Okay, there is no any loss, much loss at the gate section. So therefore the pulse gate triggering are comparatively better than as compared to your AC triggering and DC triggering. Okay, so what we have studied at the last here is in the turn on methods, if I use the forward voltage, okay, I may damage my SCR. If I use the thermal, again I may go for the destruction or the damage of my SCR. Okay, but for the light triggering, okay, this can be the one option here. But if there is no sufficient amount of light, okay, then again your SCR will not turn on properly. Okay, then we have dv by dt triggering. Okay, so that this dv by dt is nothing but change in the voltage with respect to time t. Okay, so if there is a sufficient amount of voltage which is applied at those particular terminals, anode and cathode, then your SCR may turn on. And in the last type of triggering is gate triggering. In gate we have three methods. Okay, so if I use the AC triggering, I may get the isolation, but I may face the problem that it is only the negative half cycle, it is only the positive half cycle. Okay, if I use the gate triggering, there is the possibilities that I may not get the isolation even if I get the proper both constant type of the signal, okay, with the proper magnitude and the polarity. Okay, but if I use the gate pulse triggering, okay, this is the best way of turning on the mechanism, turning on the your SCR, because along with the isolation, okay, pulse transformer can be used, which is better for isolation. Okay, and hence you need not to have to apply the gate signal continuously. Okay, and hence gate losses are very much reduced. Okay, so with this I will be concluding the today's topic of this Thyristor turn on methods. Okay, and in the next class we will be moving with the turn off method, that is natural and forced commutation. Okay, so with this I will be concluding my today's lecture here. Thank you.